going to hit record so that y'all can be YouTube famous too. And full screen. Okay, so this was the last thing that we saw yesterday, was the interval notation and the graphing the sets using interval notation. Okay, so when we left off with this example, we had the x, all values of x such that x is less than 5. Okay, so when I write it in interval notation, how did I have to write this in interval notation? How did I write interval notation for x is less than 5? I want interval notation.
Open parentheses, negative.
Good. Okay, so that was my interval notation. All numbers less than 5. The smallest value in the set was negative infinity, all the way up to positive 5. So what symbol do I have at the 5? Open circle, and I shaded which direction? To the left. Okay? So there's my interval notation in my graph. What about my interval for x is greater than or equal to 0? I'm going to have a closed circle at 0, and I'm going to shade which way? To the right. Okay? What's my interval notation going to be?
Bracket 0, comma infinity.
Apparently, this wants me to not have a bracket. There we go. All right? So, bracket, comma, infinity. Infinity always has the parentheses. Okay? So that's our standard kind of unbounded interval notation and graph of the inequality. Today, we're going to look at a compound inequality. Okay? We have two parts to it. And there's more than just this one kind of example, but we're going to start with this to keep it simple. And what we have here is we have the set of all values of x such that x is between 2 and 8. Okay, 2 is less than x, and x is less than 8. Okay, so x is between 2 and 8. We could break it apart. We could break it apart and see, highlight this first part here. Okay, break it apart, and what we have is x is greater than 2. See how we have the larger side of the inequality is staying with the x, but I can write it in a more traditional fashion so that we see x is greater than 2. So if I draw a number line, and I have 2 as a critical value, and change the color here, I can draw my inequality starting at 2 and moving to the right. X is greater than 2. If I look at the other part of the inequality, and I see that x is less than 8. So I have x is less than 8. I again have that critical value at 8, and I do the same kind of shading, an open circle because it's less than, and this time I'm going to go to the left. And so because x is between 2 and 8, then my solution set is bounded by those numbers. It's not going off into infinity in either direction. So when I write my interval notation, what's the smallest value I'm going to have? 2. What's the largest value I'm going to have? 8. So my interval is from 2 to 8. Okay? Set builder notation with the inequality, interval notation with the parentheses, and then our graph would be from shaded with the open circles at either end. All right? Now, my interval notation for my second example. So I've got all values of x such that x is between -4 and 2. All right? So what's the smallest value on my interval notation going to be? -4. And the largest value is going to be 2. What symbols am I going to use to close off my interval? Okay, so on the graph, I'll have a closed and an open. Okay, but what about on the interval? Good. Good. Okay, and then I'm going to shade in between because it's between -4 and 2. Okay, questions, comments, concerns, queries, conundrums? Cool. See, I'm learning new things as I do this, and I'm getting really excited about it. Yeah, in a minute. All right. So, now, that was the end of that first section. So now we're going to talk about operations on real numbers. So we talked about a lot of different real numbers, okay? Positive and negative, fractions and decimals. Now we're going to look at the operations, which is plain and simple. Add, subtract, multiply, divide, square roots, cube roots, exponents, all of that fun stuff, okay? Now, yes, your calculator does all of it, okay? TI-84 is a magical, wonderful tool that can do all this stuff. But you need to understand the rules that go with it, because putting in the wrong thing is very easy. Okay, it's an easy mistake to make. If I had $1, every time someone put the wrong thing in the calculator, I could have retired from that. Okay, crazy calculator stories. So you need to understand what type of answer you should expect. And that's going to save you a lot of headache at the end of the day if you can look at the calculator, you put in your operations, and you go, that answer doesn't look right. There's something off about that answer, because I expected to get a positive answer, but this gave me a negative. Or God forbid you get a syntax error, and you're like, oh crap, okay, what did I do wrong? So we need to understand the basic underlying rules of these real number operations. Starting with adding, okay? Adding real numbers. Doesn't matter if they're integers, they're whole numbers, they're fractions, they're decimals, they're square roots. Doesn't matter. If you're adding two numbers that have the same sign, you're going to add those numbers together and you're going to keep that sign, whether they're positive or negative. Think about it like money, okay? I borrow $5 from Larry, and then the next day, because I'm a moocher, I borrow $7 more from Larry, okay? How much money do I owe Larry? $12. Because I borrowed 5 the first day, and then I borrowed 7 more the second day. So I have a debt of $12. That's two negative numbers adding together to make a bigger negative number. Okay? I give Larry $5, and then I give him $7 more. I paid him back 12. I've added the values together to get a bigger positive number. Now, if I have different signs, what we do is we subtract and keep the largest one. All right? So I borrow $5 from Larry. All right? And then the next day, I come to school with $7, and now I can pay him back. Do I still owe him money, or do I have money left over? If I borrowed 5, and now I have 7 so that I can pay him back. I still got money left. I borrowed 5, and now I have 7 so I can pay him back. I got $2 left. Okay? 7 minus 5 is 2. 7 was a positive value. The debt was a negative value. Since I had more than I owed, I have money left over. And I can flip it the other way. All right? I borrow $7 from Larry, so I have a debt of $7. I come to school with $5. I can pay him back $5, but I still owe him 2 because the debt was larger than what I had. Okay? It doesn't have to just be whole numbers. It could be decimals. It could be fractions. It could be whatever. But that's the idea, is that when we have different signs, we subtract them and keep whichever value has a larger impact on what we're looking at. So I like to think about money with that. Subtraction isn't really subtraction. It's actually addition in disguise. Because what we're going to do is we're going to take our subtraction and we're going to turn. Now, there's always going to be simple math problems. 7 minus 5 is easy. You don't have to turn that into addition and then do the negative. But when we start getting into the more complex numbers, with more operations, being able to rewrite using additive inverse makes subtraction a whole lot easier. We change the subtraction sign into addition, and then we just make the second number the opposite sign. The second number was negative, make it positive. It was positive. So we use that additive inverse so that now I have an addition problem, and then I can use my addition rules. And we'll do something similar with division. We don't really do division anymore. We make it multiplication, and we do multiplication. Okay, so we don't have to remember different things and try and figure out what each thing was doing. Okay? So for this first set here, I don't even want to know the number yet. I want to know what sign I'm going to have. So if I have negative 6 plus negative 15, is my answer going to be positive or negative? Negative. Why? Because negative plus negative is negative. It's a bigger negative number. Okay? For B, positive or negative? Negative. Same reason. C, negative, same reason. All right? So let's go ahead and add now. So I know I should expect, I know I should expect negative answers on all of these. So I'm going to just add them and keep the sign. Okay? So negative 6 plus negative 15 gives me what? Negative 20. I know it should be negative, and then 6 plus 15 gives me 21. Okay? For B, I know my answer should be negative. I just need to add 1.1 and 1.2 to get negative, what? 2.3. Okay? And then fractions. Again, I know I need a negative answer, but I have to add 3/4. If I could actually make a 3. 3/4 and 5/8. Okay. What else do I have to do in order to add fractions? Yeah, I need to get a common denominator. So multiply what will give me a common denominator. What would my common denominator for these two be? 8. Okay, I've already got 5/8, so 3/4 is going to become 6/8. And now I can go ahead and add. Okay, so negative 11/8, or negative 1 3/8. All right? Doing okay? Should be refresher. All right? So find each sum. So I have 3 plus negative 7. Is my answer going to be positive or negative? Negative, because the negative is bigger. B, positive or negative? Positive. Because the positive is bigger. C, negative why?
Because the negative 2.
How do you know?
Because once you transfer it over, it's 2/8.
There you go.
That's
Make sure that you have a common denominator before you compare the size of two fractions. You have that common denominator comparison, and we can clearly see that 3 is larger than 2, so we're going to end up getting a negative value. So 3 plus negative 7 gives me negative 4. Negative 3 plus 7 gives me a positive 4. And then negative 3/8 plus 2/8 gives me negative 1/8. All right? Easy peasy, lemon squeezy. Okay. And again, your calculator will do all this stuff. That's fine. If you get hung up on it, you can use your calculator support. But there will be times that this, knowing how to do, can be faster. So investing in that time and that ability will pay off. Because one, you only have 45 minutes for your test in my class. When you take the SAT is time. And half of the math section is no calculator. All right. So it gets to a point you need to be proficient skills in order to be successful. All right. We are in a technological age. You will be allowed to use technology a lot, but you also need to understand why certain things are the way they are. So now with subtraction, again, we don't really do subtraction. We just use additive inverse. We rewrite the problem. Okay? 12 minus negative 5. We want to rewrite it as an addition problem. So I'm going to leave the 12 alone. I'm going to change it to addition. I'm going to change the sign on the second number. So that negative 5 becomes a positive 5. And now I have this wonderful easy peasy 12 plus 5 for 17. A negative 11.5 minus negative 6.3 so now we have different signs. So the large. Right? So it's just, we add this one little step in the beginning and then use the same rules that we did before. Alright? Does that make sense? And now, when we have this, we can also add more layers on. We can add more operations in a row. And when we have subtraction, what we want to do is, so I have 12 minus negative 5 minus 7 plus 13. We can take a longer expression, rewrite the whole thing as addition, And no matter how complicated it gets, we just go left to right. And just do it step by step. 12 plus 5 is 17, plus negative 7 is 10, plus 13 is 23. And just go from left to right. All right, so write the whole thing as addition, and then just go left to right. And we'll do the same thing with multiplication division. That way we end up with less confusion, more accuracy in our solutions. Okay? So I want you to keep that in mind, and I want you to try to simplify this one. Okay? So you're going to have to take the original problem, change the whole thing to addition, and then just add from left to right. Okay? I just want the solution in the answer box. You don't have to write the equation as an addition problem. You'll do that on your own with your paper. You'll work it out and then give me the solution of negative 6 minus negative 2 minus 8 minus 1. Refresh it. All right, so if I rewrite this whole thing using addition, okay, what does it become? Negative 6 what? Plus 2. Okay, and so negative 6 plus 2 gives me negative 4. Negative 4 plus negative 8 is negative 12, and then plus a negative 1 to get the negative 13. Okay, so change the whole thing to addition, go left to right. You won't always have to do that, but having that skill is going to make things a little bit easier from time to time. Okay? All right, now, let's see how much you remember of the order of operations. What's the operation I need to do first with this one? Yeah, I need to do that big set of brackets there. So if I have negative 7 plus 15, that gives me what?
8.
Okay, or positive 8. Okay, and then I now have negative 3 minus 8 minus 6. So negative 3 plus negative 8 plus negative 6. So negative 3 plus negative 8 is negative 11 plus negative 6, negative 17. There's addition, and then left to right. Right? Because when we have those negative values added in, we have to be more careful about what we're doing from step to step. It's really easy to get tripped up on what's positive and what's negative. All right. Now, multiplying, dividing, luckily, is a little bit easier in my humblest of opinions. Whenever you're multiplying or dividing, if you have the same sign, then your product is positive. If you have a different sign, your product is negative. Same with your quotients. Now, important to note that this is true when you have two numbers. If you have three numbers being multiplied or divided, then you need to apply that rule with each and every step. Okay? So the product of two numbers with the same sign is positive. The quotient of two numbers with different signs is going to be negative. But what if I had three numbers? Well, we'll deal with that one in a minute. Okay? So, I want you to look at these products and tell me which ones will be negative. Which of those products will be negative? Which of those products will be negative? All that apply. Okay, so two of those will be negative. These have the same sign, so these won't be negative. The negative 0.9 and negative 15. But since the other ones are different signs, those will give us negative products. All right? Now, talk about division. Okay, that was like really late. Really late. All right. So, when we're looking at division, we talked yesterday, dividing by 0 is undefined, okay? But we can divide 0 by anything and we just get 0, okay? Also, a side note, 0 is not positive or negative, okay? It's just 0. All right? So, be very careful when we're dealing with division and 0. So, like we don't really do subtraction, we do additive inverse, we don't really do division, we do multiplicative inverse, which is involving reciprocals, okay? So whenever we have numbers being divided, we have a quotient of anything, A divided by B. We can divide by writing the second value as its reciprocal and then doing multiplication instead. And remember that fractions are division. A over B is the same thing as A divided by B. And so instead of doing that division, we can write this as a multiplication expression and then write the reciprocal of our value. So the reciprocal is just write it as a fraction and flip it. If it's not a fraction already, then make it a fraction. And then you can flip your fraction. Okay, and then you can multiply using your real number operation rules. All right. So if I have the number negative 2/5, what's its reciprocal going to be? Negative 5 over 2. Note how we didn't change the sign. All we did is flip the fraction, switch the numerator and the denominator. What's the reciprocal of negative 6? Negative 1/6. There we go. That's a little bit better. Okay, negative 1/6. And keep the sign. Take the whole number, put it over 1, and then now we can flip the fraction. 7/11. 11 over 7. 5/100. How'd you get 20?
Over 5.
So how'd you get the 100 over 5?
It's 5 over 100.
Yeah.
And
Flip it. Okay? So this is in the hundredths place, right? So we take the decimal, write it as a fraction. Okay. Take the decimal, write it as a fraction. Since the 5 is in the hundredths place, it's 5/100. Now we can simplify 5/100. What can both of those numbers be divided by?
Oh, yeah.
So I end up with 1/20. So 1/20, its reciprocal will be 20. Okay? What's the reciprocal of 0? Undefined. There is no reciprocal for 0.
Is that a thing we could write the little circle with the flash?
That's no solution. It's different, yeah. Undefined and no solution mean two different things. So 0 over 1, still 0. But once we flip it, now that 0 is in the denominator. I can't have 0 in the denominator, so it's undefined. Okay, so 0 has no reciprocal. And we can always verify that numbers are reciprocals because their product is always 1. The product is always 1, which is, again, why the sign has to stay the same. But if I take negative 2/5 times negative 5/2, I get negative 10 over negative 10, which is 1. Okay? So reciprocals have to multiply together to equal 1. If they don't, then they're not reciprocals. And reciprocals are used more than just for division. They're used for so many different things. We'll be using them several times throughout the year. Reciprocals are a powerful tool for rewriting equations into much more manageable expressions. Okay, so with that in mind, with division, we just take the number and we rewrite it as multiplication, keep the first number, change multiplication, multiply by the reciprocal, and then we follow the same rules. The same signs is going to be positive, different signs will be negative. All right? So let's do a couple and then you guys do the next one. Now, basic ones, like just do the division. It's not a big deal. You don't have to rewrite it using inverse. You guys should know negative 15 divided by negative 3. What's my answer going to be? Positive. And then what's 15 divided by 3? 5. Okay? You don't have to go overboard. Right? But once we start getting some complex fractions and some complex quotients, then we need to use that process of multiplicative inverse. So we're going to remember that fractions are just divisions. Okay? Fraction is division. So this is the same thing as 3. It would let me write a 3. I don't like 3s. 3. I don't like this auto thing. There we go. Negative 3/8 divided by 11/16. Okay? It's division. So I can rewrite it as multiplication. First number stays the same. Division becomes, and 11/16 becomes 16 over 11. And then we can multiply. You can simplify beforehand or you can simplify afterwards. Either one is fine. Okay? So let's just go ahead and multiply and then we'll simplify. What's negative 3 times 16?
Negative 48.
Good. Negative 48. What's 8 times 11? 88. And what can I simplify both of these by? 8. Okay? So 48 divided by 8 is what? 6 over 11. Okay? So rewrite division as multiplication. Do the multiplication. Simplify your fractions. Questions, comments, concerns, queries, but the reason I like this is because
You're not always going to have common denominator.
it's not always going to be that pretty.
Okay.
Otherwise, your fraction could be upside down. If you flip the first one, it's going to be upside down. All right. Give me the quotient of 3/4 and I forgot what it said. So we need to make sure that we keep the 3/4, change the multiplication, and then the reciprocal of negative 7/16 is negative 16 over 7. The negative stays, And since we're multiplying different signs, our quotient has to be negative. And then make sure you simplify when you're done. Negative 12/7 is our solution.